Hey, so my name is Harish.
I'm Tim.
And we created the
block
accumulator.
Yeah.
Okay, so we're just going to show you how the game works. Okay, so
when we hit the switch, which is our reset, which technically pauses the game, it starts the game, and our blocks will start falling.
So the way the game works is every row is a finite state machine, and each row of blocks that we have, we keep using a shift register to shift down different states of the finite state machines. So for example, we'll have state 0, going to state 1, going to state 2, going to state 3, and it'll have different blocks in each state just following through the shift register. Obviously we used flip-flops in our implementation as well. We used finite state machines, we used shift register, and we also used hexes in our game. So every time there's a red block that goes onto the paddle, we see that the score increments by 1, right? So there's 19, 20. So right now Tim is collecting the blocks, and we use key 0, key 3, and key 2 to collect the blocks. And the other part of our project is after about every 10 blocks that are collected, the speed continues to increase. So we see here that we're probably at level 3 right now, and now we're at level 4. And then we'll see a crazy implementation where it's at level 5. So this is just, it's just some fun that we had with the game. Obviously it's not practical to collect all the blocks, but it's just a block collector. And yeah, that's the basis of our game. Is there anything else you'd like to add?
Yeah, we had a few struggles, especially with trying to implement our keyboard. We couldn't manage to get our keyboard input to work for whatever reason, but it was working with the keys on the DE2 board, so we decided to leave our implementation with that. And
yeah, another issue that we did have was we couldn't implement blocks of different colors, because you see that the way it works is each row is a finite state machine, and so the blocks itself, they're at different states, right? Each block or combination of blocks is at a different state. So when we begin to try to change each color of each state, it won't work, because when we compare the coordinate of the block to the paddle, we use that by comparing the coordinates, right, on the VGA board, on the VGA display. But when we try to set the colors of the blocks, they are set using different states. And so we couldn't differentiate between one color or the other on an individual row, which is what we had initially planned to do, and we didn't do it. But yeah, so this is our game. It was pretty fun, and it just keeps going like this over and over again. Oh, we can also show them the reset as well.
So if we hit a reset,
yeah,
which is switch 2,
yep,
then it pauses the game and puts it in a frozen state of...
Yeah, so this is just a game that's paused, and it's just in the original state 0, and it does nothing. It doesn't add the score, it doesn't do anything. And if you hit on clear,
then
if we hit on clear, what happens is, well, no, hit on clear, not the switch 8.
Oh, switch 8.
So when we hit on clear, you can see here that it just goes back to the original state of the game. You have a paddle, and you have the state 0 up at the top. When you hit on start again, or you clear the state, once again the game begins. And it begins at the last level that you left off. And yeah, so that's basically our game. We had a lot of fun doing it. It took us a lot of time, a lot of struggle, but it works well. Any last? Okay.